Assalamualaikum. My name is Aliza Kamran and I'm your biology or chemistry online tutor at Valeem. So before starting with the topic, let me give a brief introduction. So I've done my master's in biochemistry from University of Karachi, Pakistan. Right after completing my postgrad degree, I've gained the certification in ESL classes. So I'm a certified ESL tutor. Along with that, I have joined so many platforms, online educational platforms. So I have more than 5 years of tutoring experience, not just the virtual, but also physical. So starting with the topic, let's just proceed towards what we are teaching today. And here I'm starting with the topic of energy in chemical reactions. So, first of all, let's have a look what energy is, or what do you mean by energy in chemical reaction. So for a chemical reaction to take place, the molecules of the reactant must collide with each other and have the proper orientation and energy. What does that mean? Like, there's so many chemical reactions occurring, from a reaction like photosynthesis to a reaction of soft ring or the air pollution. So there are so many millions and trillions of chemical reactions are happening in our surrounding. So how those chemical reactions are gonna take place? What happens that we have two things, the reactants and the products. So what happens, the molecules of the reactants are your startup molecules. So the molecules of the reactant, they're going to collide, hit with each other, and they are always arranged in some proper orientation, and they have a certain amount of energy. So even when a collision has the proper orientation, they still need sufficient or enough amount of energy so that they can break the bonds that are present between the reactant molecules. So right afterwards, when they break the bonds of reactants, then they will be able to create new bonds and form, like, transform itself from the reactants towards the products, right? So for that whole process, they need sufficient amount of energy. Now, what does that energy means, and from where it is coming from? So this energy is known as the activation energy. Now, this activation energy is the amount of energy that is actually required by the molecules of reactant so that they break the bonds that are present between atoms of the reactants, right? So if the energy of a collision is less than the activation energy, the molecules bounce apart without reacting. Now, what does that mean? It means that if the molecules of reactant are not getting enough amount of energy, then what happens? It just bounce and it just come and do the collision and then bounce back, because they're not getting that enormous amount of energy that helps them to break the bonds between them so that they can transform itself into product, right? So whenever enough amount of energy is not present, reactants are just gonna collide and comes back into their normal position. But whenever reactants got the amount of energy known as the activation energy, they transform itself into product by breaking the bonds first. So many collisions occur, but only a few lead to the formation of product. And now we know why we're saying that, because if the molecules of reactant gets the activation energy, only then they would be able to transform itself into product. But if they're not getting the activation energy, they will collide with each other and then gets back into their normal positions, right? That's why there's so many collisions occur between the molecules of reactant, but only a few lead to the formation of product. So this concept of activation energy is analogous to climbing over a hill. Of course, that in order to reach a destination on the other side, think about a mountain, right? And you can just imagine inside your mind. So if someone wanted to reach a destination on the other side of the mountain, they must need to expend some energy so that they can easily climb to the top of the hill and reach to their targeted destination. Just like that, molecules of reactant needs activation energy. When they get the targeted activation energy, they easily break the bonds between themselves and forms the new bonds so that they can easily transform themselves into products. Now, after proceeding towards this, now what conditions we require for a reaction to occur? We did talk about that how the molecules of reactant turns themselves up into product. We did talk about the activation energy and the concept of activation energy. Now there is a very important thing that we need to remember, that what conditions are actually required or actually used for a reaction to occur. So we need the three conditions, and that is required for a reaction to occur. Collision. The reactants, the molecules of the reactant must collide, because if they're not gonna collide, the reaction won't start, right? Orientation. All the reactants must align properly, right? They should be in a proper orientation so that they can break the bond and form new bonds, right? And now the last but not the least, energy. So what happens? We already talked about the activation energy. So right after, when reactants are present in their proper orientation, they're gonna collide, but they need the collision. They need the energy of activation so that they can break the bonds and form the new bonds. Now, as you can see here, the picture, let me just use my highlighter. So as you can see here, this picture, and these are showing the two graphs. The first graph is the exothermic reaction, and another one is endothermic reaction. Now, exothermic reaction, as you can see, they're showing us a mountain hill on both the bar graphs, right? And for exothermic reaction, you can see that these reactants want that activation energy, right? This activation energy, when the reactants got the activation energy, they immediately transform itself into product, and the heat of reaction released. Now, on the other hand, if we're going to talk about endothermic reaction here, so here's the reactants of endothermic reaction. They're going to get the energy, right? But when they get the activation energy, now they have enough energy to transform themselves up into products. So this amount of energy is going to be absorbed. Now, of course, you must be thinking that how we're going to just differentiate between this exothermic and endothermic reaction. Now, let's have a look here. Before starting, or I've just given the little description in that picture, but let's take a look and have a brief word that what are the types of reactions. So there are two types of chemical reaction. The first one is the endothermic reactions, and the second one is the exothermic reactions. So first we are gonna go and start with the endothermic reactions. So endo means within, endo means inside. So in endothermic reactions, the energy of the products, they have higher energy than that of the reactants, right? Because in endothermic reaction, what happens that the amount of heat is going to be absorbed, by the reactants, right? So that they can transform themselves into products. So in endothermic reactions, the energy of the product is higher than that of the reactants. Now, heat is absorbed in endothermic reactions. For example, we have here a little example. So when hydrogen and iodine react to form hydrogen iodide, heat must be absorbed. So here you can see the example of endothermic reaction. Heat is absorbed. How? This is your H2 gas, hydrogen gas. When it reacts with iodine gas, it needs 55 kilojoules of energy so that they can transform themselves up into hydrogen iodide. So where heat is a reactant. So in endothermic reaction, your heat is a reactant because this is the reactant side and this is the product side. So when your heat is present on the reactant side, it means the reaction is endothermic. Why? Because these two reactants absorbing this amount of energy to transform themselves into the product, right? So that's why in the equation for an endothermic reaction, the heat of reaction is written on the same side as the reactant. So heat of reaction is this, and it is written on the same side as the reactants, right? Not to forget, endo means within, which means heat is going to be absorbed by the reactants in endothermic reactions, right? And just because of that, because the reactants are going to absorb the heat, then they transform into product, that's why the energy of the products is higher than that of the reactants in endothermic reactions, right? Now proceed towards another type of reaction, that is exothermic reaction. Again, exo means out, outside. So the energy of the products here is lower than the energy of the reactants. And what does that mean? It means heat is going to be released in exothermic reaction. Now let's quickly take the example. So in the thermite reactions, what happens? The reaction of aluminum and iron trioxide produces so much heat that temperatures of 2500 degrees Celsius can be reached. Now what's going to happen? This is your reactant site and this is your product site. Remember, now we are discussing exothermic reaction. Heat's gonna be released, right? That's why heat is written on the product side and not on the reactant side. So this is your aluminum. Aluminum is gonna react with iron trioxide. When it's gonna react, so the reaction of aluminum and iron trioxide is enormous. It has enough heat. So they don't require extra amount of heat. That's why when the reaction occurs between these two, they're gonna quickly transform themselves up into iron and aluminum oxide. Plus, they're gonna release enough amount of heat, right? So the thermite reaction actually used to cut or weld railroad tracks, right? So whenever there is the manufacturation of railroad, so over there you can just have a look that how the thermite reactions gonna happen. So in the equation for an exothermic reaction, the heat of reaction is written on the same side as a product, right? So heat is present here on the product side and not on the reactant side. Why? Because we are discussing this exothermic reaction. And in exothermic reaction, the heat is going to be released at the end of the reaction. And just because of that, the energy of the product is lower than the energy of the reactants, right? So not to forget, in exothermic reaction, heat's gonna be released at the end of the reaction, where if we're gonna talk about endothermic reaction, heat's gonna absorb at the start of the reaction, right? So this was I guess it with the topic of energy in chemical reaction, and I would expect that if there's any questions, you can just clear it up, and we're gonna meet soon in our future classes if you're gonna like my video, right? So don't forget to like Valeem, all Valeem channels, whether it's on Facebook, Instagram, WhatsApp, YouTube, or LinkedIn, right? Give it big thumbs up, subscribed it, liked it, and if you like me, please don't forget to book a trial lesson. I'm here. Take care. Goodbye.